we have a signal xt and if its Fourier transform is x of j omega, then the differentiation property states that if we take the derivative of the signal, then it is j omega times x of j omega. Okay, that is a differentiation property, and we can generalize this. If we take the nth derivative, then it is j to the power n x of j omega. That is the differentiation property. Now, there is a dual of this property. I am not going to explain that. It is there in the formula sheet. This is the differentiation in the time domain. If you differentiate in the time domain, multiplication with an omega term in the frequency domain, there is a dual of this. That property is, if you differentiate in the frequency domain with respect to omega, I don't remember the exact formula. There is a formula like, I think it is T something, TXT. There is a J term, I think. This is, it is somehow, I don't remember the exact formula. There is a formula like this. It is the dual of this. If you differentiate in the frequency domain with respect to omega, then it is multiplication with T in the time domain. Here, if you differentiate in the time domain, multiplication with omega in the frequency domain. So there is a dual of that property. Okay. So today let us discuss the integration property. If we consider a signal xt and let's say x of j omega is its Fourier transform. Now if we integrate that signal, let us denote it by y of t. And its Fourier transform, let us denote by y of j omega. Now is it related with this x of j omega? Is it somehow related to x of j omega? What is the derivative of yt? Derivative of yt, dy by dt is xt. Is xt. So can we say that y of j omega into j omega is x of j omega? Y of j omega into x of j omega is x of isn't it? We are yt and y of j omega, they form a Fourier transform pair. Now if we apply the differentiation property, we can write j omega into y of j omega. That is the Fourier transform of derivative of yt. That is equal to x of j omega. So can we write like this? Is there any problem in writing this? There is some issue at omega equals to 0, isn't it? Okay, there is some issue there. So we need it is not straightforward. Other than omega is equal to 0, this is perfect. Okay, at omega equals to 0, there is some issue. We cannot recover that value by dividing with that j omega. Okay, so for that, let us okay, so let us first derive that property. There is some additional term is there. We are going to derive that. So let me take a new page. Okay, if we consider xt, x of j omega, that is integral of xt. Can I write it as xt convolution ut? What is xt convolution ut? It is integral minus infinity to infinity x tau ut minus tau d tau, isn't it? So this term is non-zero only when what? Which values of tau? This is integration with respect to tau. If tau is greater than t, then it is 0, isn't it? So we can write this as because when tau is less than t, this term is 1. For greater than t, it is 0. So we can write minus infinity to t x tau d tau. Okay. Now First, let us consider this signal. So if we know that the Fourier transform is xt is x of j omega, if we can find the Fourier transform of unit step function ut, then we can use the convolution property to find this, isn't it? Because it is convolution of two signals in the time domain, so multiplication in the frequency domain. We can use the convolution property of Fourier transform. Now, what about the Fourier transform of ut? Is it a Fourier transformable signal? Is it a Fourier transformable signal? Unit step function? What is the condition for existence of Fourier transform? If the signal must be absolutely integrable. This is not a Fourier transformable signal. Okay, but in the generalized sense, we can find Fourier transform of this signal. Okay. For finding the Fourier transform of this unit step function in the generalized sense, we start with a signal. I think all of you are aware of this signal. What is this signal called? This is called the signum function. It is denoted by that is the definition of signum function. We start with the signal. Is it a Fourier transformable signal? No, this is not a Fourier transformable signal. So it is not straightforward to find the Fourier transform of this also. Let us consider this signal. Let us consider an exponentially decaying signal e to the power minus at ut. Okay. What is the expression for this signal? This part, is it minus e to the power at u minus t? Flip this part, flip this, multiply with minus 1. Will you get this? This one? This is e to the power, this part is e to the power minus at ut. When you flip this, will you get a signal like this? What is flipping operation? Replace t with minus t, is it? Then you multiply it with minus 1, you will get the signal. So this is minus e to the power at into u of minus t. Now what will happen as a tends to infinity? As a tends to infinity? Is this a Fourier transformable signal? For a greater than 1? It is a Fourier transformable signal. And in the limiting case, as a tends to infinity, what will happen? What will be the shape of this? Amplitude tends to 0. Which amplitude? Oh, sorry, it is. Sorry, it is my mistake. It is not a tends to infinity as a tends to 0. As a tends to 0. What will happen as a tends to 0? As a tends to 0, this tends to the signum function. Now, this is a Fourier transformable signal. What is the Fourier transform of this signal? What is the Fourier transform of e to the power minus at ut? This one. This is a standard Fourier transform pair. It is given in the formula sheet. 1 upon j omega. Now, what about this part? There is a minus sign. And what is the time shifting property, time reflection property of Fourier transform? If you replace t with minus t, what will happen in the Fourier domain? Omega with minus omega. So there is some problem here. I am writing it here. 1 upon a plus j omega minus, okay, and if you simplify this, you will get minus j, what, minus j minus 2j divided by 2j omega by a square plus omega square, is it? That is the Fourier transform of this signal, is it? Now what will happen as a tends to 0? A tends to 0, this signal, this approaches the signal function. What will happen here? Is it minus j2 omega by omega square as a tends to 0? Put a equals to 0 here. So we will get 2 by j omega, is it? This is the Fourier transform of the signum function. The Fourier transform of signum function, this is S, G and T, 1 minus 1, that is 2 by j omega. Okay. Now our objective is to find the Fourier transform of what? What is our objective? We have to prove the integration property. For proving the integration property, we have to find the Fourier transform of unit step function. Can you tell me how this unit step function is related to signum function? Unit step function is this. How are they related? Ut in terms of signum function. How to get the unit step from signum function? What will happen if we shift this up by 1? What is it this? Isn't it? Now tell me what is, we know the Fourier transform of this. What is the Fourier transform of ut? The first term is signum function by 2. The first term is 1 upon j omega plus what? What is the second term? Fourier transform of 1 by 2. You know this Fourier transform pair. 1, what is the Fourier transform of 1? Delta omega. Is it 1 delta omega or 2 pi delta omega? It is 2 pi delta omega. So what is the Fourier transform of 1 by 2? Pi delta omega. Is it? So can we say that the Fourier transform of unit step function is pi delta omega? Fourier transform of unit step function is 1 upon j omega plus pi delta omega. Okay. And again, this is in the generalized sense because this is, strictly speaking, this is not a Fourier transformable signal because it is not absolutely integrable. Okay. So in the generalized sense, we have found a Fourier transform for the Fourier transform of the unit step function. Now, what is our objective? We have to find, isn't it? Because we want to prove the integration property minus infinity to t x tau d tau, that is equal to xt convolution ut. What is that? What is the Fourier transform? What is the convolution property? Convolution of xt and ut. What will happen in the frequency domain, Fourier domain? Multiplication. So it is x of j omega into what? 1 by j omega plus pi delta omega. Is it that? Can we simplify this? Can we write it as x of j omega by j omega plus what? Pi into? Okay, let us write it as x of j0. X of j0, because I am putting omega 0 into delta omega, isn't it? So this is the multiplication property, integration property. The Fourier transform of integral of xt and now you can check the formula sheet. This property is given. If the Fourier transform of xt is x of j omega, then the Fourier transform of this integral, it is x of j omega by j omega plus pi into x of j0 into delta omega. Okay. What is x j0? How is it related to xt? What is x j omega? It is integral minus infinity to infinity xt to the power minus j omega t dt, isn't it? What is x j0? Is it area under xt? It is the area under xt, isn't it? Okay, so this is integration property. Now let us consider an example. This standard result we already know. 0 t1 minus t1 1. What is the result? That standard result, it is 2 sine omega is it this? Okay, now we can what is the derivative of this? What is the derivative of this rectangular pulse? There are two impulses. What is the strength of this impulse? 1, because this height is +1 and this height is -1. So this is an impulse of strength -1. Is it? Is this the integral of this? Is this rectangular? If you integrate this, will you get this? Yes. So we should be able to prove this, get this result starting from here, isn't it? Let us consider this as yt and this as xt, where xt is equal to derivative of yt. Okay. Now, can we apply first tell me what is the Fourier transform of this? Minus e to the power minus j omega t1. Is it? X of j0 is what? Is it 0? Now, what will happen if we apply the integration property? What is y of t? Y of j omega? It is x of j omega by j omega plus what? Pi x j0 delta omega. Is it? Will you get the same answer? E to the power j omega t1 minus e to the power minus j omega t1 by what? J omega. So this is same as 2 sine omega t1 by omega, isn't it? We got the same result using the integration property. Okay. Let us consider one more example. So the question is, you are given the standard result 0 t1 minus t1 it is 2 sine omega t1 by omega. You are given this result, the standard result, and you are asked to find the Fourier transform this using the properties of Fourier transform. Can we apply the integration property here? What is the derivative of this? What is the derivative of this? That is a derivative. And if you integrate this, will you get this? Because derivative of the this one is this. That doesn't mean that if you integrate this, always you will get this, isn't it? Because if there is a DC value, it will be lost in the differentiation. That's why I am asking whether you will get this signal if you integrate this. In this case, you will get, isn't it? Now tell me, what is the Fourier transform of this? What is the Fourier transform? What is the Fourier transform of this part? Rectangular pulse shifted left by how much? Half. So tell me, what is the Fourier transform? Is it e to the power j omega by 2, that is left shift? And what is the width of that pulse? Which pulse is shifted by that? Is it 0, half, minus half? So it is e to the power j omega 2 by 2 into sine omega by 2 by omega. Then, what about this? There is a minus sign. Shift right by 1 by 2. So it is e to the power minus j omega by 2 sine omega by 2 by omega, isn't it? Okay, now let us say this is yt and this is xt. So this is x of j omega. Can we simplify this? Is it sine omega by 2 by omega into e to the power j omega by 2 minus e to the power minus j omega by 2, isn't it? Now, if you apply the integration property, because this triangular pulse, that is the integral of this. So if you apply the integration property, we can get the Fourier transform of this triangular pulse. Tell me, what is the Fourier transform? It is, if you remember, x j omega by j omega plus j pi, sorry, not j, pi x j0 delta omega. What is x j0? X j0 is 0 in this case because area is 0. Otherwise, you put omega is equal to 0 here. You have to find the limit. You will get that value, isn't it? That is 0. So this term will be 0, isn't it? This term is 0. What is y of j omega? Fourier transform of this rectangular pulse. Y of j omega is what? Divided by, okay, there is a okay, this is this one. So it is sine omega by 2 by j omega square into e to the power minus j omega by 2 minus e to the power minus j omega by 2, isn't it? And if you simplify this, what will you get? Did I miss some constant here? There is some factor of 2 missing, isn't it? Okay, this is 2. So, okay, this is 2 is here. So, this is 2. This one, there is a 2 here. So, can we write this as 4 sine omega by 2 2j. So, is it this? This one. Okay. So using the integration property, we have proved we have found the Fourier transform of this rectangular pulse. Now, can you tell me, is there any other, by using some other property, you can find the Fourier transform of this rectangular pulse? Here we have used the, for Fourier transform of this triangular pulse, we started with this result. We found the derivative. This is related to this result. Using the integration property, we found the answer. Now, my question is, instead of using the differentiation property, can you use some other property? Other than this integration property? Convolution. What is convolution? Convolution of what? Two rect functions. Which are those rect functions? Standard rect functions. That means 0, 1 by 2, minus 1 by 2. Isn't it? This also you'll get the same answer, isn't it? If you convolve these two, this one, is it? Will you get the same answer? What is the Fourier transform of this? 2 sine omega by 2 by omega. And this one is what? Same, right? 2 sine omega by 2 by omega. So it is 4 sine square omega by 2 by omega square. You will get the same answer. In this case, if you can quickly identify that it is convolution of two rectangular pulses, then using this is easier than this integration, using the integration property, isn't it? Okay. We have considered two examples, and in both the cases, this xj0 is 0. Now let us consider an example where xj0 is not 0. That is a problem from the tutorial sheet. I think it is the third question in the tutorial, second or third question. This is the question. 1, minus 1, and this is 1, and this is 2. Let's say this is the given xt. You have to find the Fourier transform of this, starting with this 2 sine omega t1 by omega, and using the properties of Fourier transform. Okay, so what is the derivative of xt? Derivative of xt? This one, isn't it? This is 1, 1, minus 1. Is it? This is the derivative. Is this the integral of this? Let's say this is x1t. Half. Amplitude will be? By? Oh, okay. No. I think, no. This is 1 by, minus 1 by 2 to 1 by 2. This is the question. Okay, then the amplitude is 1. It is minus 1 by 2 to 1 by 2. This is linearly increasing. After that it is 2. Here it is 1. What is the Fourier transform of this? x1 j omega? What is that? 2 sine omega by 2 by omega, isn't it? If we apply the integration property, that is minus infinity to t x1 tau d tau, what is the Fourier transform? What is x1 j0? 1, isn't it? So what is the Fourier transform of this? It is x1 j omega by j omega plus, because I'm considering this signal as x1, pi x1 j0 into delta omega, isn't it? That is integration property. Is it? Tell me what is the Fourier transform of this one? Oh, sorry, it is. Yeah, it is. It is the Fourier transform of the integral of x1t. So x1 j omega is this. So it is 2 sine omega by 2 by omega j omega square, isn't it? Plus this is 1. Is it this? Is it? This is the Fourier transform of integral of this signal. Now our objective is to find the Fourier transform of xt. How is it related xt and x1t? Is this the integral of this? But how much is that constant? So can we say that xt is equal to integral minus infinity to t x1 tau d tau plus what? Plus 1? Is it? Now we got the Fourier transform of this. Now what is the Fourier transform of xt? So 2 sine omega by 2 by j omega square plus pi delta omega plus what? What is the Fourier transform of 1? 2 pi delta omega, isn't it? So the answer is this plus 3 pi delta omega. Is this the answer? Okay. So you have to be careful about this DC value. If you integrate this, if you are not getting this value, you have to add a DC shift. Okay.